A support agent can look magical in a demo. One prompt, one model, one tool, and a refund appears. But the demo hides the hard questions. Who is the user? What was authorized? What happens when the provider times out? In production, the model is only one component. Our running example is a customer asking for a duplicate charge refund. The agent is not just drafting text. It may move money. That makes identity, policy, approval, and a durable record part of the product, not optional infrastructure around it. The naive design connects an LLM directly to tools. It is fast to build and dangerously easy to misunderstand. A fluent answer is not authorization, a tool schema is not a policy, and a retry is not safe unless the action is idempotent. We will build the missing layers around one refund request: intake, orchestration, model and tool gateways, state, durable work, security controls, traces, budgets, and evaluation. Keep watching the same request. Every layer answers a specific production failure. The request first enters an authenticated intake layer. Confirm the customer, tenant, session, and requested outcome before asking a model to reason. If identity is vague at the beginning, every downstream decision inherits that ambiguity. The orchestrator owns the workflow. It gathers context, asks the model for a bounded plan, routes each step, and decides when to stop or escalate. The model can propose. The orchestrator remains responsible for execution state. Put model access behind a gateway. That is where you choose a model, pin prompt versions, apply safety rules, handle provider limits, and record usage. Your agent should not scatter direct model calls across business code. Tools need their own gateway too. It exposes a small, typed capability surface, validates arguments, applies authorization, and rate limits, and normalizes errors. The model never receives raw database credentials or unrestricted internal APIs. Conversation state stores what has been said, the current goal, and the workflow checkpoint. Keep it explicit and versioned. Do not rely on the model context window as your only memory, because retries and workers need the same durable state. Retrieval supplies approved refund policies and order facts with citations. It informs the decision. It does not grant permission to issue money. Keep knowledge access separate from action authority, so a helpful document cannot become an accidental credential. Record requested, proposed, approved, executed, and resulting states. For a refund, capture who requested it, which policy applied, the exact tool input, and the return transaction identifier. If money changed, you need a trail. Customer profile data, invoices, knowledge documents, and payment actions have different sensitivity. Give each step the least data it needs, for the shortest time it needs it. The agent should not see an entire customer estate to answer one refund question. Refund providers can be slow. Move long-running actions onto a durable queue, so the interactive request does not wait forever. Persist the workflow checkpoint. Acknowledge the user, and let a worker resume when the provider responds. Timeout does not mean failure. The provider may have completed the refund before the connection broke. Retry with the same idempotency key and return the existing result. Otherwise, your reliability mechanism can duplicate a real payment. Set explicit timeouts and isolate unhealthy dependencies with circuit breakers. One failing invoice service should not consume every worker or freeze unrelated conversations. Bound the blast radius and offer a controlled fallback. After bounded retries, move the task to a dead letter queue with full context. A human operator should see the request, policy, attempts, error, and safe replay action, not reverse engineer the failure from scattered logs. The tool must know which user and tenant the action represents. Mint a short-lived, scoped identity for this one refund operation and carry it through the queue. Service identity alone cannot explain whose authority was exercised. Separate read permissions from refund permissions. The support agent may inspect an order, but only a narrowly scoped tool can issue the refund. Deny unrelated operations by default, and make every granted capability easy to explain. Autonomy should stop at the risk boundary. A low risk, policy-compliant refund may proceed automatically. A high-value or unusual request pauses for human approval. The threshold is a product and governance decision, not a prompt trick. Evaluate policy before the tool runs, then append the decision, policy version, identity, inputs, and result to an immutable audit record. Prompts can guide behavior, but enforcement belongs in deterministic controls outside the model. Give the entire request one trace identifier across the agent, model, retrieval, queue, and tool. Then an incident responder can reconstruct what happened without stitching together 5 unrelated dashboards. Track tokens and model latency, but also tool calls, queue delay, retries, approval wait, final outcome, and user experience. An agent can be cheap per token and still expensive because it loops or calls slow systems. Set per user and per run budgets for tokens, time, and tool calls. When the limit is reached, stop cleanly or escalate to a human. An autonomous system without a stopping rule is an unbounded reliability and cost risk. Capture anonymized production traces and replay them against prompt or model changes with tools disabled. Compare policy compliance, action selection, clarity, latency, and cost before release. Test the workflow, not only the final sentence. Now the shape is clear. Authenticated intake, orchestration, model and retrieval gateways, durable state, a constrained tool gateway, approval, queued execution, audit, and observability. The model reasons inside this system. It does not replace it. Run a failure drill. The payment provider times out after accepting the refund. The durable task retries with the same idempotency key, discovers the existing result, and informs the customer once. Reliable agents recover from evidence, not guesses. Not every task needs an agent. If the rule is fixed and the path is known, use a deterministic workflow. Use an agent when ambiguity, context gathering, or judgment genuinely earns the extra operational burden. Before shipping, ask, do we have identity, durable state, a tool gateway, approval boundaries, safe retries, traces, and budgets? Which control would you add first to an agent you run today? Put your answer in the comments. We will turn the strongest cases into follow-up videos.